Okay, this video is to show you how to diagnose some common faults with the Space Ice Maker, Samsung Ice Maker. The model of this particular freezer is that one. This ice maker, let me show you inside. May also be found on some other models. It looks like that, but this is the model of freezer it's in, fridge freezer. Okay. Now this may not be the slickest of videos, but there's so many videos out there talking nonsense or trying to sell your product. I've got nothing to sell. This video will show you how to find some common problems, and in this instance it was the thermal fuse that I replaced and cost £2. So first though, you need to verify that the rest of your ice maker is working. If you see there's a test switch on the side here, right there, press and hold, it'll beep and it'll run through the cycles. You'll hear the motor working, etc. Most importantly, you want to ensure that water is getting into the tray. Okay, if the water pipe is blocked, that's something else and it's not covered by this video. If you're unsure, you can disconnect the pipe on top of the fridge freezer right here, unscrew this screw, take this plate off. There's two screws beneath that and there's like an L-shaped hose which will come out, and you can see the water when you run the test. Press the test button and run the test sequence, you'll see water squirt out of it. Okay, right, let's get on with it. First you need to get this part out. As I say, it pulls out towards you after you've unscrewed here, taken this panel off and disconnected the metal. This is on like 2 pegs. It needs a bit of force to bring it out towards you. Just one screw to undo this panel here. This is where the electrical connections are. Once you remove that panel, you're going to want to undo this multi-plug here. So bear in mind this is live 240 volts in here, so I mean I'd be tempted to unplug the machine before we do this. And the ice maker itself here comes out with a bit of a shove in this motion. It's like 2 pegs up in the top there. So just yank it towards you and it'll unclip. So directly straight back. Make sure, well, I'll probably unplug it first because you don't want to pull it and yank the cable. The cable will come with. Okay. You'll see, when it's off, you'll see exactly what I mean. So here's the part number on this one then. As I said, you can just replace this unit, or if you want to go a bit further, here's what we do. So what you want to be doing is measuring on the connector pin between the pink and grey wires. Now your probes might be a bit big on your multimeter to get down these little connectors. If they are, see what I've just done is I've put a couple of pins in. So get your meter on resistance again, and we're going to measure between the blue, because I've seen the blue end of that pin there. It's between the grey and the pink. Right, here we go then. We're going to measure between the grey and the pink, and knock a few things over that I've just got set up so you can see it. So that's perfect. Grey and the pink cables. And so we're getting nothing between those two there. So that means that's open circuit, which these two are the cables that supply power to the heater element. So believe it or not, there's actually a little heater in here. When the ice cubes are frozen, just like a normal ice tray, it gets stuck to it and the motor hasn't got the power to push them out. So there's a little heater underneath that heats the bottom of the ice tray and just melts them and makes them all slippy and slidey, so the fingers of the motor can push the ice cubes out. What you're hearing, if you hear that roo, 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 roo noise, that's the motor trying to push out the ice cubes and not getting anywhere, or just cycling round and round and round. So we've proved that the heater circuit is the heater element is open circuit. So we need to investigate to why. Or you can just chuck it away at this point and replace this for 100 quid. But it may well be the thermal fuse in here, which costs about 2 quid. Right, we've got our ice maker unit on the bench. So let's get on with the strip down then. It's basically removing all the screws you can see, but there's one here. One there, one there. One at the bottom there. That removes this plastic section that snaps out so you can see the element inside, and this gets the lid off so we can get under that. Let's whip them off then. One screw at the top here to remove. There's a screw inside of this arm to remove, and then one on the bottom of the top. Oh, that's right, yeah. There's one here at the back of this the control box where the motor and everything lives, and then this plastic lid will snap off. There's a little tab at the bottom. Just gently pry that with a flat blade screwdriver. Okay, when you remove that, we're getting pretty close now. It's just the last few screws. There's these two here. They remove this arm. I think this is the arm that sort of dangles down. I think it's something to do with measuring the ice in the box and turning it off. And then the last three here that hold this gear in, hold the gearbox housing, and then you should be able to split the white bit from the brown tray down this line here. It'll pull apart, and that's where the thermal fuses live. When you've got the gearbox apart with the motor off, you'll find the gear inside. Make sure the teeth are intact, because when the heater element fails, the drive motor tries to drive this cog, gear, whatever, to turn the bar that pushes the ice cubes out, and because it's all frozen up and can't move, it rips the teeth off this cog, and then you might get away with a few missing, but I can't find this part anywhere online. There's a lot of nonsense talked about this part here. This is just a little magnet. If you look on the board here, it's got two Hall effect sensors there. So as this magnet goes past the sensor, it registers here, so the computer knows where the wheel is in relation to the paddle and everything else. I've not seen these fail. It'll be fine. When you've got everything stripped out from here, this part, the ice tray, will then pull away. I'll show you. Pull away from here, look, you see the gap, and that's where you will reveal inside there are the thermal fuses. So I've got the ice maker component all down, stripped apart. So just to recap, we've got a multimeter in ohms. That's the horseshoe one there. So we're measuring horseshoes. And to recap, so the pink connectors, which is the heater element, this warms the bottom of the ice tray just to melt it, to allow, so it's not stuck to the ice tray, to allow the rotating pusher to push the ice cubes down to the floor. So to recap, when we go to the plug on this one, we're getting open circuit. So I'll just show you the meter there, look. Hang on, see if I can stand him up. So it's showing open circuit across those two terminals. So what I've done, I've stripped it all down, and we've got two components here, and then it leads on. I've stripped the wiring back. This was covered in heat shrink. This is directly to the heater element itself. So the next thing we're going to do, we're going to measure the resistance across the heater element. So if that's open circuit, we know the heater element, this U-shaped thing at the bottom here, is unserviceable. So if we get a resistance here we know that that's serviceable, and the fault will be one of these two components here. So let's measure that resistance of the heater element alone. See if I can, I'll tell you what, you can see what I'm measuring there, and then I'll move you back to see the meter. Hopefully that should help. Here we go then, so just the heater element itself, bosh bosh, approximately 400 ohms. That suggests that heater element is okay, that's good news. So I think what these are, some kind of thermistors or something. I'll have to look what the part number is on them. But if we go, what I've done, I've stripped the heat shrink back at both ends now, or you could have used the pins in there. I accidentally stripped these ones. I stripped the wrong side accidentally, but it matters not. I can soon put more heat shrink on it. So let's go across this first one here. Measure across that. 10 ohms. Measure across the other one. Open circuit. Oh, again, let's do that once more with the multimeter in a shot this time. Sorry, it's quite tight. I haven't got a lot of space. I've got bits of fridge freezer all over the place. So again, I should see that better now. Here we go. Bottom one. Yeah, even better, 8 ohms. So open circuit, top one. Sorry. Bottom one, let's start again. Bottom one, around about 10 ohms. I've got 8 at 1.65. That's just down to my push it on properly on the connectors. Okay, bottom one, around about 8 ohms, so that's closed circuit. Top one, open circuit. That leaves me to suggest this component here at fault. As I say, I think there's some sort of thermistor. I'm going to have a look at the writing on it. It's far too tiny. Get a magnifying glass, look at the writing, order one of them up, and hopefully replace it. Okay, the new thermal fuse has arrived. I called it a thermistor earlier in the video. I meant thermal fuse. It's slightly physically smaller, but it shouldn't matter. It's still 3 amps. It's still 250 volts. It's still 102 degrees. So I'm going to cut this one out, cut, and solder this one in. Right, notice I've put some new heat shrink over here. Put your heat shrink on before you solder it up. Otherwise, maybe obvious, you won't be able to get it on. Sounds obvious, I've done it 1,000 times, forgot, and had to snip it and do it again. Back to your thermal fuse, it's not polarity conscious, you can connect it either way, it makes no odds, so don't worry about that. That's the the replacement fuse, sorry. Soldered in and heat shrinked. Right, what we've got to do now is reassemble this and give it a test. Oh, I'll tell you what we ought to do. Before we do that, we'll just test continuity at the pins to make sure. Let me put you in stand and we'll do that. Here we go then. We've got our meter. Let's bring that in there. There you go. You can see that meter set to resistance. There we go, 6 ohms in the leads. I'll just do these 2 pins. There we go, around 400 ohms, 376. We had about 400 ohms is what we measured on the heater element itself. So that suggests we're all good. Okay, let's get on with reassembling it. Boom. Ice.